Ever wonder how your phone can sort vacation photos by how sunny they look, or how an app might guess your age from a selfie? It's not magic. It's something called visual embeddings, and they're more powerful than we ever imagined. Let's break down how this works and why it's a game changer for AI. So, what's a visual embedding? Think of it like a digital fingerprint for images. When you upload a photo, an AI model doesn't just see it. It converts it into a list of numbers or a vector that captures its key features. These vectors live in a high-dimensional space where similar images cluster together. That's why search engines can find similar photos. But here's the twist. What if these vectors could do more than just find matches? What if they could rank images along a scale, like how old someone looks, how crowded a scene is, or even how modern a photo feels? That's exactly what this research explored. The team asked, can these embeddings naturally align images along a continuous scale, like a ruler? Imagine a line from youngest to oldest. Could the AI place photos along that line in the right order? The answer, yes, and often with surprisingly little data. They tested models like ResNet, ViT, and clip across datasets with attributes like age, crowd size, and aesthetics. And here's the kicker. You don't need thousands of labeled examples. In some cases, just two images, like a child and an elderly person, were enough to define a rank axis. The model calculates the direction between those 2 points and uses it to sort new images. It's like teaching a kid to sort toys by size. You don't need a full set of blocks. You just show them the smallest and largest, and they figure out the rest. This means apps could let you scroll through photos sorted by how young you look without training a new model from scratch. No massive datasets, no complex code, just smart math. Why does this matter? It opens up new ways to organize visual data. Imagine an e-commerce site ranking products by formality, or historians sorting old photos by era without manual labels. The study also challenges how we think about AI. If embeddings naturally support ranking, maybe they're capturing deeper, more structured relationships than we realized. But how do we measure this? Let's dive into the numbers. At the heart of this study is a statistical measure called Spearman's rank correlation. Think of it as a ranking accuracy score. Imagine asking an AI to order photos from oldest to newest, or from ugliest to most beautiful. This metric tells us how well the model understands the patterns behind those rankings. The higher the number, the better it's grasping the big picture. Looking at the results, different AI models show wildly different skills. Take ResNet 50, a classic image recognition model. It scores 0.563 on one test. But Conv XTV2L, it jumps to 0.765. And here's the twist. The best scores come from models that are fine-tuned for the task. One model hit an impressive 0.93, like a student who not only studied the material, but also practiced the exact exam questions. But wait, what if we don't even train the model? The no-trained baseline shows models struggle, with scores as low as 0.324. That's like a student guessing on a test. However, researchers found a clever shortcut. Applying a simple math trick, like linear regression on pre-trained data, can often beat specialized systems. It's like using a basic calculator to solve a complex problem, instead of building a supercomputer. Now let's talk about image recency, figuring out when a photo was taken. Here, even top models like DNV2 VTB/14 only manage a 0.131 correlation. That's like a toddler trying to guess the century of a painting. But when researchers train models specifically for this task, performance jumps, proving that specialization matters. What's the takeaway? Sometimes the simplest tools, like tweaking existing AI with basic math, can unlock surprising power. It's a reminder that innovation isn't always about building something new, but about refining what we already have. So next time you see an AI sorting photos by age or beauty, remember, it's not just about raw power. It's about how cleverly we teach the model to understand the world around us. Thanks for watching. If you want to dive deeper into how AI models think, hit subscribe. And let me know in the comments, what's one attribute you'd love to rank images by?